Hello everyone, welcome to another GIS Mathematics lecture video. And in this lecture video I want to continue our discussion talking about the determinant. So in the previous example we left off talking about this idea of a cofactor. And we said that the cofactor was, some row and some column was equal to -1 raised to some power I plus j times this thing called the matrix minor, which was the determinant of this matrix minor, which was basically just a matrix made by ignoring row I and column j. So we have this equation here. What I want to talk about now is something called cofactor expansion, which allows us to calculate the determinant for matrices larger than 2 by 2. So I want to talk about cofactor expansion. And what I want to do is I want to lay out the equation in this video, and then I want to talk about how we approach it in some examples in the next video. So cofactor expansion is basically using the cofactor along a single row or a single column, summing all the cofactors along a single row or a single column. So let's take a look at what this would look like. So the general form of the equation looks something like this. So for the ith row, so this is for the ith row. It's going to look something like this. That's 1 times the cofactor I comma 1 plus a I comma 2 times the cofactor I comma 2 plus a at I comma 3 times the cofactor at I comma 3 plus the a at I comma n times the cofactor at I comma n, and that's supposed to be dot dot dot. So let's break this equation up really quick and look at the different pieces. So the first piece we have here is this a I comma 1. So this would be the value in the matrix This is the value in the matrix at location I comma 1. Right, the C, right, I comma 1, right, this is that cofactor, right, so this is the cofactor. For the matrix minor for the location for the row I in column 1. Right, again, remember the cofactor, right? We're ignoring I and we're ignoring 1. So by doing this, right, we're multiplying the value of the matrix at location I comma 1 times the cofactor, which is the matrix which ignores row I and column 1. And then we're adding to that, right, again, this is the value in the matrix, I comma 2, times the cofactor at I comma 2. So take a step back, think about the parts of this equation. All right, so again, we have the value times the cofactor, which ignores that row and column, plus the value times the cofactor that ignores that row and column, plus the value times the cofactor that ignores that row and column. And we keep going until we've done every single column in the row. So I is a row, and then we're just going down column by column by column by column by column. And this would be for the ith row. And again, the cofactor expansion sums all cofactors along a single row or a single column. So this would be for the ith row. Let's go ahead and look at the Let's go and look what this will look like for the column. So this would be for the column. So this is row cofactor expansion. This is going to be column cofactor expansion. It's going to look very similar. All right, you're going to have the value. In this case, we're going to start with the first row, and we're going to use the jth column, or column j, right, times the cofactor for that same set, right, 1 comma j, plus a 2 comma j times c 2 comma j. Again, right, we're multiplying the value times the cofactor at ignoring that row and that column, plus a 3 comma j times the cofactor of 3 comma j. And then we would plus, and then dot dot dot, and we would go all the way down to the end of the matrix. So the nth column, nth row for the jth column. All right, so this is just the end of the matrix. And again, same concept. We're multiplying the first value times the first cofactor matrix, second value times the cofactor for the second, third column value times the cofactor for the third row, etc., etc. We keep going until we get to the end of the matrix, add them all up, and that is the cofactor expansion. So I know this equation looks a little daunting perhaps, but let's go ahead and just quickly walk through some examples in the next video. If you have any questions, please reach out. Thank you.